Write the factored form of the polynomial function p of x that has a leading coefficient of -4, roots or zeros of multiplicity 2 and x equals 3 and x equals 0, and a root or 0 of x equals -5. We can write the factored form of a polynomial function in the form of p of x equals a times the quantity x minus r sub 1 to the power of m sub 1 times x minus r sub 2 to the power of m sub 2, and so on, where the r values are the distinct roots or zeros, the m values are the corresponding multiplicities, and a is a leading coefficient. Which means in our case, because the leading coefficient is -4, we have a equals -4. The roots or zeros are 3, 0, and -5, which indicate the r values. Let's let r sub 1 equal 0, r sub 2 equal 3, and r sub 3 equal -5. Because the roots of x equals 3 and x equals 0 have multiplicity 2, this indicates m sub 1 equals 2 and m sub 2 equals 2. The multiplicity of the root or 0 of -5 is not mentioned, and therefore it's 1, giving us m sub 3 equals 1. This is all we need to write the polynomial function p of x in factored form. We have p of x equals a, which is -4, and then times x minus r sub 1 to the power of m sub 1, which gives us the square of x minus 0, times x minus r sub 2 to the power of m sub 2, which gives us the square of x minus 3, and then times x minus r sub 3 to the power of m sub 3, which gives us 1 factor of x minus -5. Let's go ahead and simplify. We have p of x equals -4 times x squared times the square of x minus 3 times 1 factor of x plus 5. This is the function rule for the polynomial function that satisfies the given conditions. Before we go, let's analyze the graph of the polynomial function. Recall the roots or zeros of a polynomial function will be the x-intercepts of the graph of the polynomial function. And notice we do have x-intercepts at -5, 0, 0, 0, and 3, 0. Also remember, when the multiplicity is odd, we'll pass through the horizontal or x-axis, and if the multiplicity is even, the graph touches the horizontal or x-axis and then bounces back. Notice our graph does pass through the horizontal axis or x-axis at x equals -5, and then it touches the x-axis at x equals 0 and x equals 3, and then bounces back. And then finally, because the leading coefficient is -4, and the degree of the polynomial function is 5, as we move to the left, or as x approaches -infinity, the function values increase without bound and approach positive infinity. And as we move to the right, or as x approaches positive infinity, the graph goes down and the function values decrease without bound and approach -infinity. I hope you found this helpful.